So looking here, it gives you a couple different options on how to do this. I'm going to tell you right now, this first one, this is the way I'm going to work them out. Okay? As opposed to this one. Which just by looking at it.
Sure.
Yeah. So, first looking at multiplication, what you're going to do is you're going to take the numbers that are in front of the radicals and you're going to multiply them together, and then you're going to take the terms inside the radicals and you're going to multiply them together.
What?
Okay? Easy enough.
Hang on. 3 times 18
is 54. A squared times a squared is a to the fourth.
Okay.
Now once you're here, you're then going to simplify the radical down if you can.
Okay.
So we've done this before. Alright? So you're going to simplify that down. We've done this before. This is what's the largest perfect square you can divide it by? This one is 9. 54 divided by 9 is 6. And then you still got the a to the fourth. They wrote it differently here than the way I normally would. I would write it all underneath one radical. There's not a reason to write it underneath 3 different ones. The square root of 9 is 3. The square root of a to the fourth is a squared. And so whenever you pull stuff out of the radical, you multiply it all together. That's going to give you 12a squared. And then the 6 is still underneath the radical. Okay? Over here, essentially what they did is they simplified each radical first, and then they multiplied it together. I would multiply it first and then simplify it. I think that's a little bit easier. The second way, it's a lot of little steps that if I did it that way, it'd probably be riddled with mistakes all the way through it. Okay? So going to the division example here, same idea. I take the numbers that are in front of the radicals. So I've got 1 and 4. So I'm actually going to start this as 1 over 4. And then after that, I'm going to take the radicands, whatever is underneath the radicals. And if you need to, you can go off to the side and divide those. And what's 18 divided by 3? 6. What's a squared divided by a squared? 1. They cancel, right? So I'm left with the square root of 6 over 4, because of the 1/4. I think the biggest, probably the most common mistake that's going to happen is, okay, I do 18 divided by 3, which is 6, but do I put the 6 in the numerator or denominator? Okay, most of you can do 18 divided by 3. It's just where do you put it? It's always going to go in the numerator. Okay, so let's work out a few of these examples. So let's look at these. Number 1. First thing I'm going to do is look at the numbers in front of the radicals. It's multiplication, so what is 2 times 5? 10. So I've got 10 times the square root of x squared. I multiply the two things that are underneath the radicals. And then what is the square root of x squared? X. So my answer on this one is 10x. So going to number 2. What is 1 times 4? 4. Someone tell me where I got the 1 from right there. Because there's nothing in front of the first radical, so you're going to find a lot of the rules, and not just this, but a lot of other. It's going to be very similar to dealing with variables. Okay, there's an understood 1 in front of it. So now I go inside of there. What is 18 times 3? 54. What is a squared times a squared? So now I need to look at that number. What is the largest perfect square I can divide 54 by?
9.
What is 54 divided by 9?
6.
And then now, once I have that, I pull out everything that I can. The square root of 9 is? The square root of a to the fourth is what? a squared. We'll talk about that in just a second. And now once I have everything out of there, it's going to be 12a squared times the square root of 6.
Find the GCF between 9 and 6. How do you get 3?
Why do you leave?
The square root of 9 is 3.
Why do you leave 6?
Because I can't simplify it anymore. Once I have 6 under there, I can't divide it by a perfect square.
2.
2 is not a perfect square. So, one thing on here. Listen, whenever I ask this question, there's kind of a little bit of silence. Whenever I asked you what the square root of a to the 4th was. Okay? Don't overcomplicate this. Think, whenever you're taking the square root of it, that's the same as raising it to the power of what? 1/2. What is half of 4? 2. Now, don't write that out every time, but know that whenever I'm taking the square root of a variable raised to an exponent, I'm just dividing that exponent by 2. That's all I'm going to do. Here, the square root of, well, that's cube root, but, okay, the square root of a squared is going to be a. The square root of x to the 4th is going to be x squared. The square root of x to the 6th is going to be x cubed. You're just dividing that exponent by 2 if it is square root. So now let's go over here, and I'm not for sure why it's written that way, but I mean it's the same thing as what we've been doing. We're multiplying those two things. So first, I'll look to see what is out front. Think of it as the coefficient of the radical. So 2 times 1 is 2. Here I'm dealing with cube root. And then what is k times k? K squared. So 2 times the cube root of k squared. And whenever I do that, can I take the cube root of 2? Or sorry, whenever I do, can I simplify the cube root of k squared? No. Okay, that's as simplified as it gets. Now, that's written in radical notation. You will, if I was to write this with a rational exponent, is it going to be k to the power of 2 over 3 or 3 over 2? 2 over 3. Okay? Now, listen, if you're asked to answer this, and this is, let's say this is the answer you get, and it's free response, and you put what I have written up top, that is 100% correct. But if it's multiple choice, you're most likely to see it with a rational exponent. It will benefit you more to convert it to where it has a rational exponent than leaving it in that radical notation. Okay. Let's go to 4. So again, I'm going to look to see what is out in front of each radical. So I've got n, and then I don't have anything in front of that one. So that is going to be n. Then I have the cube root. What is 4 times 2? What's n times n squared? N cubed. And then now, what is the cube root of 8? 2. So I don't have to simplify this one, which is nice. What is the cube root of n cubed? N. So I get that. So my answer is going to be what? 2n squared. Questions on that, or any of the ones we've done so far? So next we got division. Now you saw this one already worked out up top, but whenever you see all the steps at once, it doesn't always process. So make sure you're going through it with me. So first I've got that one right there over 4. So again, I'm going to go ahead and set it up like that right there. All right, what is 18 divided by 3? 6. Oh, man. What is a squared divided by a squared? 1. Cancels out. Do I put the square root of 6 in the numerator or the denominator? Numerator. Will it always go in the numerator? Yes. Okay, and then that looks kind of weird, so I'm just going to rewrite it to where it looks like a normal fraction. I want you to attempt number 6. I'm going to challenge what I want you to do, and I'm going to give you some guidance because it's not like, oh, here's a multiplication or division problem, just a little harder, because obviously it has addition in there. What I want you to do is I want you to do 7 times the square root of h multiplied by 3 square roots of h, and then 7 square roots of h times 4 square roots of h cubed. Take it one piece at a time. Multiply the numbers in front, then you do the square root, multiply what's underneath. You're just doing that process twice. So with what I asked you to do, you should have gotten 21 square root of h squared plus 28 square root of h to the 4th. Now what is the square root of h squared? So I've got 21h. What is the square root of h to the 4th? What is 21h plus 28h squared? No, don't play math, God. Do what? Why can't I do it? Because you don't have like terms. Okay? See what I did there? That's a segue into what we're going to talk about next. Yeah. Okay. So that is as simplified as it gets right there.
You look so genuinely offended.
It was.
I knew that.
So now, getting into adding and subtracting radicals, which is combining like terms. It's just now the terms look a little different, but it's not that difficult at all. Okay? The index and the radicand, for you to add and subtract, they have to be the exact same thing. Now, if you're unsure as to what those two words are that I just said, I want you to write this. Index is what's up front. So square root, the index is 2. Cube root, the index is 3. Fourth root is 4, whatever. The radicand is whatever's underneath the radical. Those two things have to be the exact same. Okay, I can't do the square root of x plus the square root of 9 and combine them. Okay, it's different, the x and the 9. So looking at this, which of those have like terms?
The ones that have the square root x.
Do what? Say the first.
I hate the fourth and second.
First and second.
And the fourth.
Wait, doesn't it turn into...
The fourth. It has the same thing. It goes four.
Liv, why is it the last one?
Because the 1/2 is the same thing as square root.
Okay, so you've got to remember that raising something to the power of 1/2 is the same as doing the square root. So, just so that if you reference back to this later, that is the same as this. So that you'll know why we said that those were like terms. So put boxes around all those. Are the remaining two, we're going to have fun with shapes and colors here. Are the remaining two, are those like terms? Why not? They're both cube root.
Because the one radical.
Because you've got x to the fourth, and you've got x. So those would not be.
That's another time.
All right.
Answer, but
Now I do want you to see this because this confused some people last class. They thought this was 7 to the power of 3. They thought it was 7 to the third square root of x. So they thought that was a like term. We're not going to give you something that looks like that. Or, this isn't going to have an exponent right next to, okay? If it does, it's going to be very clear. It would be written something like this. Okay? So just so you know, something where the formatting would make it confusing, we're not going to do that. So, coming down here, you can see why I think this stuff is pretty simple. 2 times the square root of x plus 6 times the square root of x equals 8 times the square root of x. So it's like terms. So 2 plus 6 is 8, so that's my answer. It's just like combining like terms with regular variables. All right. This term is the cube root of x squared. They both have it. 16 minus 10 is 6. So that's your answer. Okay? Not very difficult, I don't think. But let's see. Number 1, what's that going to be?
0.
Good. Make sure we're all on that same page. All right. After that, Alan, what am I going to do on the next one?
You'll add 9 and 5.
Leave it alone.
No, you can't.
Can't do it. Why not?
Because they're not like
Because they're not like terms. On these, I'm just going to put this. No like terms.
you put not applicable.
If you want to. Number 3. So, I asked that for a certain reason, and I didn't say what I'm going to say on 3 for a certain reason, because you need to be able to catch it. But the first thing you need to ask yourself, are those like terms? Because if it's no, awesome, your job's easy. That's your answer. Unless you're Lyndon, then you're at something weird. Okay? But then, if it is like terms, then you have to do whatever the operation is. So, are all 3 of those like terms? Yes. So what is 2 plus 1 plus 5? 8. So 8 times the square root of x. Going to number 4.
You don't add the x's.
Are those like terms? Hold on real quick. Do what?
You don't add the x's again on
No. You'll never change. So whatever you're looking at for it to be your like terms, if you're adding and subtracting, you won't change that. If you're multiplying, you will. Or dividing, you will as well. So on 4, again, are all those like terms? So what is 7 minus 4.1 plus 2.4? 5.3 times the square root of h. Okay, so now looking at 5, 5 is starting to combine operations. So you've got distribution, and then you got subtraction. So first thing I'm going to do is this right here. 3 square roots of t times the square root of t. What is 3 times 1? Okay. What is t times t? T squared. Minus, what's 3 times negative 8? Negative 24. What is t times t? Okay. Are those like terms? Yes. What is 3 minus 24? Negative 21. Make sure you do not stop there. I've had a lot of people in the past that would stop right there, because can I simplify that anymore?
Yes.
Yes. What's the square root of t squared? So negative 21 t. Probably the funnest thing you're going to do all day.
probably.
Probably. So on number 6, Aiden, what's the first thing I'm going to do? Why not?
answers.
Because it's not going to do anything because it's really weird. There's no like terms. Why is there no like terms?
Because one square and one's cube.
One square root, one is cube root. Now, I'm going to get you started on 7, and then I'm going to want you to finish it. Because I'm multiplying two binomials, which, what is that process called?
Multiplying binomials.
No. FOIL. Okay? So, I'm going to take this 6, I'm going to multiply it by that. So, 6 times the square root of 10 is what? 6 square roots of 10. No, not the square root of 60. Alright, so I want you to do, you're going to do all of FOIL there. And I want you to see how far you can get on this problem.
I'm doing well. Oh. That's right. Oh, yeah, yeah. I just wrote mine as a little. That's where I got confused. Did you get it right? I did get it right. I just wrote my 6 kind of thing.
So let's look at this from here. First, are there any like terms that I can combine?
Yes.
Yes.
What?
6 and 1.
Okay, 6 plus 1 is
7.
7. So the first term and the last term.
Where'd you get the 6 and 1?
Wait. Oh, I see.
6 square roots of 10 plus 1 square root of 10 is 7 square roots of 10. So now looking at these two, can I combine these two? No. Can I simplify this one? Can I simplify this one? What is the largest perfect square that I can divide 20 by? Okay, 4. Alright. Now, what is the square root of 4?
2.
2. So my 7 square roots of 10, my 6 square roots of 5, stay there, plus 2 square roots of 5. Now can I combine any like terms?
Yes.
Oh,
Yes,
get
you
it.
can.
I love the confidence there, El. That's awesome. So 7 square roots of 10 plus 8 square roots of 5. Going to the challenge. So on this one, this has a lot to do with simplifying the radicals, because obviously you can't combine any of them the way they are now, but they're all pretty big numbers. And I think there's a good number of you who can probably do this process in your head. You just got to slow down and make sure you walk through it correctly. So let's look at this. I'm going to look at this first term. What is the largest perfect square I can divide 50 by? 25. What is the square root of 25? 5. So I bring a 5 out. Okay? And you could even take it to that step, but I'm going to go ahead and write 2 times 5. What is 50 divided by 25? 2. And then I still have that x in there. Let me walk through that whole process again with you on the next one. So I've got plus 3. What's the largest perfect square I can divide 18 by? 9. What is the square root of 9? So I'm going to pull that 3 out, multiply it by the 3 that was already there. 18 divided by that 9 is what? 2. I want you to try to finish the rest of that.
No, because you do, so you do 32 and then
Oh, I
it's
thought you
16
were
and
saying
then
2
square
times
root
4
is
is
16.
16.
I'm
That's
really,
what I
I'm
did,
really
right?
bad at
What do you
like simple
see?
math. Yeah, 4 and then
There we go.
Where's the X skills, coach?
where?
Oh, no.
now that I have that,
Now you can do.
I can look for my common terms or like terms. So I've got my square root of 2x's, and then I've got my square root of 2's. So on the 2x's, 10 minus 12 is going to give me negative 2. And then 9 minus 35 is going to give me negative 26.